the shift in our consciousness about the nature of our world. We're going from the flat Earth to the geocentric Earth, and this would be spherical. So we thought it was flat, we thought it was geocentric, we thought it was heliocentric. Sun-centered. And now, chronocentric. Chronocentric, time-centered, respecting that everything is moving through time, and that is what gives us the impression. That's what creates the physical illusion of three-dimensional motion. And so this is chronocentric, and it's also a better way to look at this is to understand that as far as cause and effect goes, there is a hypersymmetry. So chronocentric, hypersymmetric. And this is Astrotometry HD. The HD version of Astrotometry understands that the cosmos is hypersymmetric. And so you could say that it's an extension of the holographic universe model. You could say that it's an extension of the various electric universe theories and stuff like that. But there's actually a geometry underlying the nature of the hypersymmetry that is also responsible for the primary forces in nature. And so in Newton's day, he resolved with his analysis, with his mathematical calculus of the nature of reality, that we have these forces. And he figured out that the force of gravity is big G, little g, mass 1, mass 2, divided by the radius squared. At or near the surface of the Earth, this has to be qualified, which is 9.8 meters per second squared as acceleration. And so there's a force, and this g is considered to be this force that's related to a mass times its acceleration. But underneath this, what the mass is, this is what astrotometry is changing. It's explaining what this mass is, and it's integrating Einstein's concept that matter and energy are related in a component relationship that is proportional. There's a proportionality between the nature of matter and energy, and it's transformational. And so I'm not going to throw the math for astrotometry out yet. But these are the things that I'm working with as far as working that out. The problem, the biggest problem as I see it, with the conventional understanding, where we fell on our crutch, we depended on Newton with this idea of a force. This was an abstraction. Newton abstracted the concept of a force. What a force is was never explained. So you've got this big F here. And we have 4 of them in our modern understanding. Gravity, electromagnetic force, strong force, and weak force. Now these have been unified in mathematically as far as I know. There are other theories that try to unite all of these. Einstein was trying to do this. The way that Einstein was approaching it was with something he called teleparallel gravitation. And teleparallel gravitation supposed that when you see this photon that comes from a distant star, so you've got this point of light, you've got the Earth here, because of the nature, because of the very nature of the electromagnetic spin entanglement. In other words, because of the fact that this photon is coming from this distant star, and we know that it's spin entangled with the one that went the other way. That was the big mind blower. That was the big unexpected feature to the nature of light. And the way that Einstein tried to approach this problem was brilliant. He supposed that there was this thing called teleparallel gravitation. And so he realized that the other end of the photon had to just happen to coincide with something like this was hitting in order for the spins to be the same. And so he supposed that gravity itself was somehow teleparallel. Somehow it moved hypersymmetrically with everything in motion. And so that was his concept, and that was the basis for his unified field theory. Now, underlying the nature of the photon is this hypersymmetric hypertime translation that I presented. And the way that this is treated in astrotometry, the reason, if you think of what a force is, what it is, it's a tendency for something to move. So it's a tendency for something to move in a particular direction relative to something else. Now, there are obvious directions to explain this with what I've presented with the concept of how something is astrotometrically translated. If you just consider what I've said about the nature of the movement of a single particle through time, it's easy to see how the interference patterns that a particular particle would have. You go back, return to our single particle. It's easy to see how that if there was another waveform that this encountered on its way, that this particular direction would be prejudiced by the position and node relationships to the other patterns around it. And so what the forces are just falls into place with this theory. That what the forces are falls into place with this simple analysis of how these patterns move relative to one another through time. And so in a very real sense, it was the dependency on Newton's observational analysis that I think prevented a more advanced way of understanding the nature of movement and time to be developed. We depended too heavily on what a force is. We abstracted this for too long. We let this go. We let this be this sort of mystical, magical thing without trying to figure out how it was actually working. And if you consider the nature of the physical objects, if you consider the nature of the characteristics of particular elements, particular molecules, as they relate to the forces, to the electromagnetic force, to gravitation, you can see the sort of order of the forces that falls out. It has to do with the characteristics of the patterns itself. As they harmonize, as there are harmonic interference patterns,